Welcome back, grade 9 Natanasov, Gates, Hollerith, Hopper, Iverson, and Neumann, and welcome to the learning activity sheets instructions for quarter 4. This is week 4, and this time we're going to talk about collision. In collision, basically we call this banggaan. Okay, and then in our discussions, dalawang uri ng banggaan yung i-discuss natin. The first kind of banggaan or collision is when the objects stick together after the collision. So may mga objects na after nilang nagbanggaan, they tend to get stuck with each other. So for instance, merong dalawang kotseng nagbanggaan, and then yung isang kotse ay mas mabigat at mas mabilis kumpara dun sa isa pang kotse. When they collide, we can just expect na kakalad ka rin nung mas mabigat at mas mabilis na kotse, yung mas maliit at mas mabagal na kotse kasi mas mataas yung kanyang momentum. Okay, so kakalad ka rin niya yun. Yung pangalawang uri naman ng collision usually is seen sa mga bola. Okay, so may mga bola na kapag nagbanggaan sila, magbabounce sila palayo sa isa't isa. And then, may mga times din naman na, halimbawa sa billiards, in a game of billiards, usually nangyayari to sa game of billiards na kapag hinit na yung white ball, tapos it hits another ball, usually, di ba yung white nag-i-stop siya, tapos like, na-transfer yung motion dun sa isang bola. So, that is another kind of collision. Okay, so it's one example of a collision where the objects are going to bounce apart. Kahit na ganun, nag-stick man sila or nag-bounce apart man sila, we can still say that in those collisions, momentum is conserved. Pag sinabi natin conserved, the total amount of momentum before yung collision is equal to the total amount of momentum after the collision kung walang mga external forces na kumbaga ay nakialam. Okay? Walang external forces na nag-alter ng kahit na ano dun sa system natin. Ayan. If that is so, wala talaga ibang forces, we can also say that those yung total amount of momentum before and after are including forces, involving forces that are equal and opposite. That is similar to Newton's third law of motion, the law of interaction. Hindi yan law of force, okay? It's the law of interaction. In this last, there are two types of collisions to be discussed. Kapag elastic collision, yung total kinetic energy at saka yung total linear momentum niya ay nakakonserve, hindi siya nagbabago before and after. Kapag naman inelastic collision, yung total linear momentum niya ay nakakonserve pero hindi yung kanyang total kinetic energy. Yung conservation ng kinetic energy is determined by calculating the total kinetic energy of all parts of the closed system before the collision and then comparing the total kinetic energy of all parts of the closed system after the collision. Doon natin siya makukuha. The next part of this LAS is a discussion about the conservation of momentum. And I think what you can see here is meron ng problem solving. So let's consider halimbawa these two model cars. The writers are designating the blue car to have 1.2 kilograms. Okay, hindi lang nailagay ng mga writers pero kilograms yan. And then yun namang red car is 1.4. And so they collided, no? Colliding at the speeds that are shown. So ano yung speed ni blue car? It's 1.2 kilograms and its speed is negative 0.5 meters per second. And then ito naman 0.2 meters per second. They are actually quite slow. Okay, if you're gonna ask me. Ayan, the total momentum before the collision is the sum of both the momentums, o yung mga moments. Alright, I'm not really sure if it's momenta. Okay. Now, for PA, MA, V, And then that is for car A, or the in this case the blue car. And then ito naman, momentum of the red car is solved as PB MB V. Okay, so that is naman the momentum of the red car. And then based on this solution, we will be getting 0.6 kilograms meters per second for the blue car, and then 0.28 meters kilogram meters per second for the red car. The writers would like us to note that the red car is traveling in the negative direction, so the momentum is subtracted. Okay, so magkaiba yung directions nila, kaya dapat yung sign nung isa is negative. The negative one is the red car. And then what you'll be getting there is 0.32 kilograms meters per second. Ayan. I think there are two scenarios being described, pero that should be described. Pero it's only one in this example so far. Let's proceed down there. Ayan. Parang your LAS is not giving you letter B, it only has letter A. So I don't really see the necessity for this anymore. Pero let's go ahead. If the two cars stick together after the collision, kung halimbawa nagdikit sila, okay, and move as one, then the velocity or VAB of the cars can be determined because the total momentum after the collision is the same. It's gonna be 0.32 kilograms meters per second. Yung total mass niyan ng dalawang cars is going to be 2.6 kilograms, which is really not realistic. Okay, they're not realistic. The total momentum after the collision is 0.32 kilograms meters per second. So what you have to do is you just have to substitute that to the formulae. Okay, so in this case, we got the momentum. We also have the mass, pero we don't have the velocity of the two cars since they got stuck. Okay, di natin alam yung velocity nila. So what it did here is, even though, okay, please remember, even though the writers here forgot about it, always show your units, okay, in your solution. Even, yes, in your solution. So huwag niyong gagayahin ito. It's 0.32 kilograms meters per second is equal to the mass of the two, which is now 2.6 kilograms. And then multiply that by velocity AB. And then when you equate that, it's gonna be, okay, di rin pinakita ng writers natin dito, pero the reason why 2.6 is right there on the other side of the equations because we divided both sides by 2.6 to cancel it out in this side, leaving behind VAB. So ito yung natitira dito sa side na to, as shown here. Now, when you divide that, you will be getting, according to the writers, 0.12 meters per second. Why? Because nag-cancel out na yung kilograms. Okay? Okay, so since canceled out in kilograms and we're supposed to look for velocity and what we got is meters per second, that means our answer is more or less correct. At least it has a correct unit. Now, the writers would like us to note that the velocity is positive, so this shows now that the two cars move off in the positive, so that's like from left to right direction. Okay, another kind of collision is perfectly inelastic collision. Kapag perfectly inelastic siya, yung mass, yung final mass is equal to the combined mass of the two objects, the way that we did a while ago. And then, the two objects as well, they travel together with one final velocity after the collision. So, in this case, we just have to use this formula. So, what does this mean? There will only be one velocity, okay? And then, it will equate the sum of the two momentums. Okay, and then i-divide yun with the sum of the masses of the two objects. So, yung M1 dyan is the mass of the first object in kilograms, and then yung M2 naman is the mass of the second object in kilograms. Yung V1 naman is the initial velocity of the object in meters per second, and then yung V2 naman is the initial velocity of this second object in meters per second. Yung final velocity lang ang hinahanap natin, and it's right there sa may kabila. Okay, so for the problem, let's have an example here. I'm just gonna scroll down a bit. Okay. So sample problem is for Aira. Aira is going by a slippery snowy hill. So Aira has a mass of 20 kilograms. So she is very light. And she's sliding the hill at a velocity, sliding down the hill, I think, at a velocity of 5 meters per second. Ada's elder brother has a mass of 30 kilograms, still a young one. Her brother is moving slower with a velocity of 2 meters per second. So Ada collides to her brother with her brother. Then both of them keep going down the hill as one unit. So we need to calculate the resulting velocity of Ada. And if they are together, then we have to that means as well that that is the velocity of her brother too. So the givens are the following. So M1 and then V1 are both eras. So you can see it's 5 meters per second and 20 kilograms. And then M2, V2 naman are from Era's elder brother, which is 30, who is 30 kilograms heavy and is moving at 2 meters per second. Okay, so substitute lang the givens in our formula. Tapos, you'll be getting velocity is equal to 3.20 meters per second. That's the same velocity. It's the combined velocity of Era and her brother. Now, it is asking here that you do this one right here. It's another problem. Problem B is a 3,000 kilogram truck traveling at 50 kilometers per hour strikes a stationary or a car that is at rest. That is also 1,000, that is anyway 1,000 kilograms heavy. So the two vehicles lock together. So they are now moving as one unit. What you need to look for is the final velocity of the two vehicles. You just have to do what we did in Era's and her brother's problem. And then you just have to calculate how much of the initial kinetic energy is lost in the collision. Yeah, that is a new offer for you. That's a new challenge for you. Okay, now it has here part A. It says here before and after an inelastic collision. Before the collision, sa isang inelastic collision, say a 3,000 kilogram, ayan siya. This is stationary. And then this one is the truck that was being described yata kanina, no? Okay. Pero it's not like this, no? Hindi naman siya like pupunta sa taas. In reality, it's just gonna drag it. It's just gonna drag it. Hindi naman siya mapapatong kasi in reality, mag-slide off lang naman yan. Okay, so for the solution, the writers put it like this. So part A, to find the final velocity, remember, that momentum is conserved before and after the collision. So dapat, yung total momentum before is equal to the total momentum after. And the writers were asking us to use this formula right here. So MT VT, that's the momentum of the truck, plus MCVC, the momentum of the car. It must be equal to the mass of the truck and car combined, and then multiplied by the final velocity, which is I think what we're looking for. So what it did here is it substituted the given. So as you can see, this is for the truck, and then ito naman ay for the car, and it's obvious because meron siya 0 kilometers per hour. Remember, the car was at rest. And then the final velocity is right here. I think dumoble lang siya dito. Okay, so just proceed with the solution. What you do here at this point is you divide both sides by 4,000 kilograms. Okay, and then what you'll be getting here is 37.5 kilometers per hour. That is going to be now the final velocity for the combined truck and car. Okay. Pinagsama na yung truck and car doon. Next one, for part B naman, you have to find the amount of kinetic energy lost in the collision. Kailangan malaman mo kung ano yung nawawalang amount of kinetic energy dun sa banggaan. Okay, so we need to find the kinetic energy just before the collision and then after the collision. Kinetic energy before the collision, the formula for that is 1/2 of the momentum. At tapos, square mo yung velocity. Tapos, ito naman, 1/2 of the momentum, pero dapat square mo muna yung velocity. Okay, so the next part, it was substituting the givens. Ayan siya. And then, the next part is, I think, ginawa na niya yung, hiniwalay niya yung first part. Tinanggal na lang niya yung first part. Bakit kaya? Because if you square 0, you'll get 0. Multiply that by 1,000, you get 0. And divide that by 2, that's gonna be still 0. So you just have to remove it. Okay? Now it says here, let's leave it at that for right now. Next, we need now to find the final kinetic energy. So, how do we do that? The kinetic energy after is equal to half of the combined, ito yung combined ha, yung mt plus mc, combined masses, and then the velocity must be squared. So what it did here is it only substituted the givens. Now, we have to, remember this is before and then this one is after. Okay, so divide KE after by KE before to find the ratio between the values. So, it says here that the ratio is going to be 3/4. What does that mean now? 3/4 of the total kinetic energy of the system remains after the collision. Therefore, we are losing 1/4 of the energy in the collision. Um, yes, you have to perform muna the following operations so that you'll understand how 3/4 was taken. I suggest that you also review operations with fractions so that this becomes easier for you. Okay, our learning competency for this week is infer that the total momentum before and after the collision is equal. It's just actually, you should be able to understand the law of conservation of momentum. Okay. Okay, now what you have to do are the following. I am requiring you all to please do the following things. Okay, so a photo or a screenshot of your answers to activity number 1, conservation, it's the law, must be posted in your portfolio. Please check your output and make sure that you also indicate the score, okay, of your output. Okay, so in that is giving you 3 questions. And then for the next part, activity 2, crashes, the objective of this is you have to be able to predict what you think will happen in each of the cases being described here. So you're just going to predict basically what you know about collisions already, about the conservation of momentum. Okay, so you need to put a screenshot or a photo of your answers to this question. You don't need to check your work here. You just have to show me your answers, and please make sure that you put them in your portfolio. Okay, the next one, it's activity 3, momentum bashing. You have to identify if the indicated or described situation is elastic or inelastic. Okay, you have here 5 items. What you need to do is you have to attach a photo or a screenshot of your answers to your portfolio, and you also have to make sure that you have checked your work and you also indicated the score. Okay? Okay, napansin nyo na rin siguro kanina, the next one is about quarter 4, week 5. So, this ends the last instructional video for collisions. Okay, so please stay tuned for further instructions, and for now, I am going to dismiss you.